Hello, everyone. Welcome to our session, to our fireside chat. We're happy to see so many people joining us today, and it's my great pleasure and honor to introduce you to my co-host for this session, to Paulina. She's one of the co-founders of Neptune.Ai and has been in machine learning for over almost a decade by now, helping teams keeping track of model training, scaling up the MLOps practice. And for the last couple of years, she spent her time working with top AI teams that are training foundation models, and that's what we're here to talk about today. Welcome, Paulina.
Thank you so much for the intro, Kilian.
Yeah, and also before we move on, let me quickly introduce myself as well. I'm Kilian. I've been working with Neptune on technical content for quite some time now, mostly around their blog, where we cover all things relevant to training models and ML engineering. And together with Paulina and many others at Neptune for the past few months, we've been working on a report on the current state of foundation model training. And that report is not quite out yet because we're still waiting for people to approve quotes and cross-check that we represent their work and their insight that they shared with us, that we're representing this correctly. But what we'll do in the next 20 or so minutes is to talk about some of what we can share already about the state of foundation model training in early 2025, I guess. And actually, Paulina and I haven't had the chance yet to sit down properly and reflect on what we've learned while we compiled this report and did the research and all the interviews. So I'm quite excited to be having this conversation with all of you today. Our session was announced as foundation model training from infrastructure to evals, debugging, and optimization, and that's just a lot of ground to cover. And so I thought I'd kick us off with a very simple question right at the beginning by asking you, Paulina, if you can give us your personal foundation of what a foundation model actually is and what that term means to you.
Well, I actually usually go back to the definition from the Stanford report from, I believe, 2021, which kind of made this term really stick. And they describe the foundation model as a model that is trained on a broad set of data using self-supervision at scale, which you can then adapt to tons of different tasks. But the key idea is that it's not a finished product. It's more like a starting point, something that you can fine-tune or customize, simply depending on what you need to do. And you kind of ask, what's my personal definition? So personally, I like to explain foundation models using actually house building analogy. And that works especially when I'm talking to people that maybe aren't so deep into the tech space. I ask them to simply think of, strong and solid foundation, and you can build all kinds of things on top of it, from house, a skyscraper, or even a bridge. And foundation model kind of works in a similar way. It's an AI model that's been trained on tons of data and can support all sorts of tasks like understanding text, generating images, and all kinds of cool stuff that we've been already doing it with it so far. But just like foundation isn't a complete building yet, a foundation model isn't the final product either. You still need to add the walls, rooms, and all kinds of stuff to make it fit the specific purpose. And that's where the fine-tuning or adapting the model comes in. But here is the important part. It's just like you wouldn't use the same foundation actually for building a small cabin and a massive bridge. You also need to pick the right foundation model for the job. Because if you start with the mismatched one, quite likely you are going to run into troubles later, and we start to learn about them, as we speak. But on the other hand, if you choose well from the beginning, you got a stable and reliable base to actually build something great, and that's actually something that it seems that quite a lot of organizations are struggling right now. Really.
Yeah, I think that building analogy, that's a great metaphor. I might actually steal that for one of my upcoming texts. And I know that you've been working with teams training foundation models, probably even even before that term was actually coined or widespread, since the very early days of transformer models. But recently you've spent a couple of months very systematically interviewing the teams working on foundation models, which also laid the groundwork for the report that we mentioned. and that we're about to publish. And as the editor of the report, I'm actually quite curious to know why you were interested in doing that report at this point in time, right? Because I mean, you have a lot on your plate as a co-founder of a startup. You're building a product, like you're releasing new products, right? But still, you decided to take on an additional obligation of doing lots of interviews with like people in academia and startups and enterprises. Can you like tell us a bit about why you decided to do that research now and take that on?
Good question. I think people that knows me better, I think their answer would be that I like to overwork. But I guess on the subject, well, as you've mentioned at Neptune, we're building an experiment tracking tool, and pretty much when the first versions of of GPTs came out, and even earlier, we decided to stay close to the most demanding builders out there. They're actually focusing on training foundational models. So for me, it just makes sense to get out there and talk to the people that are actually doing the work, even if they don't use our product. As I want to really understand like what they're up against, and how we can ensure that we are building the best possible tool for them. But obviously, it's not just about that. What really got me interested in doing this report was really a few things. First off, well, we all see all those big names in foundational model training making headlines. But there are so many other companies out there doing really incredible work that don't always get the spotlight. And I really wanted to dig into what they're focusing on, what specific problems they're trying to solve with their models, and simply why they are not just using something off the shelf. Plus, obviously, it's fascinating to hear about those real-world challenges and best practices these teams are discovering. So I guess if someone else is thinking about building own foundation models within their company, I believe we gathered some insights and brought it into this report, which could be very valuable. And I guess I'm also treating it as my small contribution to help the community move forward.
Yeah, I mean, let's just jump right into some of what you've found in your interviews, because I'm sure that like many people in the audience, just like me, like we've used foundation models, we've prompted them, we've maybe fine-tuned one, but I think training a foundation model from scratch is an entirely different endeavor. Like I don't even know if I would like feel ready to take that on myself. It seems quite daunting, but still there are like many teams and companies doing that. Can you tell us a bit about like why they are doing that? Is it because they cannot find a suitable open source model to use, and what kind of problems are they trying to solve? Right, you mentioned in the beginning that like the foundation has to match what you're building, and so I'm also quite curious to learn like what kinds of issues or problems are they tackling?
Yeah, I hope you ask that. So there's such a wide range really of companies that are training foundational models right now, and not just the big names we all hear about. And the problems they're tackling, they're truly fascinating. But broadly speaking, we've seen 4 main types of cases. One would be companies simply building very small task-specific models for niche use cases. We also would see the organizations that are building in-house models for data control, privacy, and ownership reasons. Another one would be companies that are investing in internal expertise, and this is more of a long-term strategic move. And there are also those that are taking more of a hybrid approach, so they're mixing in-house training with fine-tuning open source or proprietary models. Now diving into the first category. So yeah, there is a lot of companies that are very focused on solving some industry-specific problems. And here we talked to folks in healthcare, finance, manufacturing, even a governmental agency. So here, they are not trying to build the next GPT-5. Mm-hmm. They're solving very targeted problems for a very specific context that it's known to them, right? That are kind of very niche, very theirs. Then the ownership, as I mentioned, is another big theme. Many teams simply don't want to rely solely on the third-party tools. They want to have a visibility and the control over both models and the data. And that's, of course, especially important when you're working with some sensitive information or maybe regulated environments. And then there is the strategic angle. So a lot of companies told us that they're building this capability not just to solve the problem today, but they're trying to make sure that they are ready for what's coming next. And it's all about growing the internal know-how, also attracting top talent, and staying competitive, right, as the landscape shift. And finally, a lot of companies also are being kind of smart at combining approaches. So maybe they would train something in-house for one task, but fine-tune an existing model for another. So it's not like it's all or nothing. There is a flexibility and control. And as I brought kind of at the beginning of your first question, actually having the right foundational model for the right task is essential.
Oh yeah, definitely. I mean, thanks for this overview. That's a lot of information in there. So maybe we can go through it a bit step by step. I don't know. Are you able to give us some examples, specific companies or examples of the first category? I think the companies that are focusing on a specific, maybe a niche application in the industry, very targeted. Are you able to name some names or give examples that people might know?
Absolutely. That's where it gets interesting, right?
Exactly.
So as I mentioned, there is a variety of teams that are approaching the problems with their own foundational models, and of course, I cannot talk about each company I've been speaking with, but I can pick a few cases. So take DeepL, for instance. Most people would know them for their incredibly accurate translation tools.
Yeah.
And what's cool is that they've been quite deliberate when it comes to that they've been developing their large language model specifically for translation, and it's not just a feature; it's actually the core of their entire product. And they've been quite early when it comes to when they started working on this. Then there's ClearEye, which operates in the banking and financial industry. And they had a great quote, and I hope that I remember it pretty well, that if I have to solve a particular problem, I don't need 80 billion parameter model. So, for them, it's going huge. They built a suite of smaller, very specialized models, and each one is kind of fine-tuned for things like fraud detection or translation analysis, but it's very a focused, I would say, practical approach. Another great example, really interesting one, I can think of is Silurian, because they are building foundation models for air simulation. And this case is incredibly data sensitive, intensive in that case. And we are talking about a single training data points being multiple gigabytes. So in their case, the biggest challenge isn't really the model architecture, but it's the engineering part, just, keeping the GPUs fed fast enough. So their work is, it's all about tackling those massive scale infrastructure problems. And I guess one more I can brought up would be Kaiko, working with medical imaging. And in their case, for example, they're dealing with the rare but incredibly important features in medical scans. So they use techniques like synthetic data generation to make sure that their models can actually learn to spot these very, subtle but critical patterns. And their foundation model work is hyper targeted to those those medical cases. And I'm thinking, yeah, I think maybe that would be pretty much it. But
I mean, there's already like 4 examples. That's a lot more than I had hoped for that you would be able to name. So thanks a lot for that. And I think we can, like, this is a nice segue also into the next topic I wanted to discuss with you, right? So like we've now heard a bit about like reasons why companies might decide to train foundation models themselves, why they want to take it on. But I mean, that's just the first step, right? We can make a decision today that we want to train our own foundation model, and we maybe like have a use case where we think it could be useful. But the next step is to actually do it, right? And I'm sure that you've seen like lots of different teams go through that process, right? Learn that. And what would you say are like the main challenges along the way that teams are facing?
Well, that's a really important question. And we like to talk about the problems, so it definitely came up with every conversation that I had. And I guess the most obvious bet of everyone, if you would ask, I guess, would be the something related to the infra or in general like technical issues. Yeah. But while they are definitely challenging, I would say the most consistent struggle that was mentioned was actually around the people, meaning building an in-house expertise, but also like finding the right talent. Well, obviously, the field is relatively new and highly specialized. So finding folks that understand how to train foundation model is tough. And it's not just about hiring great AI researchers. You also need people who are great at the hardware side, distributed systems, data pipelines, and then how to fit it all together. So a lot of teams talked about the effort that it's needed to build the strong and performing teams.
And do you think that, like, aside from like talent, which is obviously very important, like like the first building block, is there like I don't know, would you say that there's like a secret ingredient? Like, so what sets like the top teams apart from the rest of the pack? Is there something which you've identified, which you think people should focus on more, or like should focus on right from the beginning?
Yeah, sure. Obviously, people it's one thing, and there's a lot of pains around the hardware and infrastructure as well that I didn't touch, but we can also skip that. And actually, like if I would have a good answer to the question you just asked, I think it would be a millions worth question, right? And I would maybe keep it to myself. But the truth is, I don't think I have a universal answer here. What I can say is that while hiring the right set of people, it's absolutely essential. What also sets the high-performing teams apart is how they set these people for success, like with the right tools, systems, and generate visibility across the entire training pipeline. And that means everyone involved, from research to infra, has a clear view of what's simply happening, like how those pieces kind of interact and where things can be improved, right? And yeah, like speaking of the right tools for the job, taking an example from my kind of world, from an experiment tracking piece of the pipeline, for example, like being able to branch off from a promising run without losing a full context, can save huge amounts of time and compute. It also helps team to stay focused and avoid burning GPUs on experiments that they don't make sense to keep on training, right? So also when things go wrong, like a model is not converging or showing some strange behavior, you need to debug it fast. And having an access to detailed losses, gradients, and activations across all layers helps pinpoint exactly where things went off track. So yeah, like at Neptune, I'm lucky to speak with folks that are working at the top labs or worked there in the past, and now they are like starting their own companies. because they've seen what good and bad looks like, and they already know what kinds of tools they will need 6 or 12 months down the line. And their insights definitely help us shape product roadmap and ensure that Neptune is the right tool for the job, and help research teams to be more efficient and more productive. So I would say great people matter, but the team that consistently succeed are the ones that build also robust systems to support them.
Yeah. And I think speaking of things that people are working on 6 to 12 months down the road, something that I was really surprised by when I started working on this report, when you brought me on for that, is that there are a lot of people that are either already training on-prem or are moving away from the cloud to on-prem. And I wondered if this changes something for you as a tool provider. And also more generally, what that means for the MLOps landscape, which so far, at least in my experience, has been very focused on cloud offerings, SaaS tools, right? And now it seems that we're moving back, kind of into our basements, onto our own service again.
A good question. Actually, sometimes it's I tend to say that it almost feels like a bit of a shift back, from everything moves to the narrative, which we've been seeing. I would say maybe that's not the best way to say it, but pre-GPT times. There were such one day. But this shift towards the on-prem infra has, I would say, significant implications for the companies like ours that build tools for foundational model training, but in general, as you said, MLOps. It means that we need to be ready to support requirements of on-prem environments, and sometimes it's even air gapped or even a Faraday cage. We've seen such. So for us, here at Neptune, we are offering not just an on-prem version of our platform, but we've built our self-hosted deployment specifically to meet the realities of foundational model training at scale. And what I mean by that, it's our architecture allows to scale Neptune alongside the training workflows without ever becoming a bottlenecks. Because we believe that building tools for this new era of the model training means understanding that infrastructure reliability and scalability aren't just nice to haves. They're just absolutely essential. And that's exactly what we prioritized in Neptune.
All right, thanks a lot. And I'm looking at my clock here that tells me that we're almost out of time. So thank you very much, Paulina, and thank you everyone in the audience. We gave you just a glimpse into what this report is going to cover. I didn't get to even have my questions that I had prepared. So please stay tuned, watch our social media channels where we'll be announcing the release of the report. And Paulina, so if people want to continue that conversation with you, ask more questions, I know they've I've just seen lots of questions pop up in the chat as well. Where can people find you online and reach out?
Please connect with me and reach out on LinkedIn. I would be happy to have some follow-up conversations if someone's interested. I believe I was able to share my profile here on the chat, so I just did. So go ahead and let's connect on LinkedIn.
All right, and with that, thank you everyone again. Thank you again, Paulina. It was a really great chat, and have fun at the conference. Lots of great talks coming up, and if you like to continue the discussion, please reach out and keep your eyes out for that report.
Thanks.
Have a great day. Bye.
Bye.